Distributed systems have a surprisingly difficult problem. Where should data live? Imagine you have 3 servers and millions of users. You need a deterministic way to decide which server stores each user's data. The obvious solution is to hash the key and take the modulo of the number of servers. For example, hash a user ID and compute hash mod 3. It's simple, fast, and evenly distributes data across the cluster. The problem appears when the cluster changes. Suppose you add a 4th server. Now every calculation becomes hash mod 4. Suddenly, most keys map to completely different servers. Nearly all your data needs to be moved across the network. Consistent hashing takes a different approach. Instead of mapping keys directly to servers, it maps both servers and keys onto a logical ring. Every server gets 1 or more positions on that ring, and each key is assigned to the first server encountered while moving clockwise. Now imagine adding a new server. The new server only takes responsibility for the keys that fall between its position and its predecessor on the ring. Every other key remains exactly where it was before. Instead of moving almost all the data, you move only a small fraction of it. The same property helps when a server fails. Only the keys owned by that server need to be redistributed. The rest of the cluster continues operating normally. This dramatically reduces the amount of data movement and makes scaling practical. Real systems go one step further with virtual nodes. Instead of placing each server on the ring once, they place it multiple times. This creates a more even distribution of keys and prevents one server from accidentally owning a much larger portion of the data than others. This is why systems like Cassandra, Dynamo, and distributed caches rely on consistent hashing. It's a simple idea with a huge impact. Adding or removing servers no longer causes a massive reshuffling of data, allowing clusters to scale smoothly as they grow.